Okay, so this is the second part of 3.2, Chapter 3, Section 2. This will be your second assignment. Here we're going to be talking first about remainder theorem. This is a slick trick. Find the value of a function. We're also going to talk about repeated zeros and finding polynomials given zeros. Let's take a look at the remainder theorem first, though. So if I have a polynomial, which is 4x squared plus 12x plus 5, and I want to find what the value is at -1. What we're going to do is we're going to take this. Now, obviously, what you would do is put this in your calculator. However, you're going to use this when you don't, and you will not have a calculator periodically in here. You use this to find it out. And what you do is you put this number right here into synthetic division. So I'm going to have a -1. And you put it in directly, because that's the number you're trying to find. And then we put my coefficients in here. I've already from squared to x to 5. Everything's there. So I write my coefficients down: 4, 12, and 5. Remember, you bring 4 down, multiply, then add, then multiply, and add. There's my remainder. Now, the remainder happens to be the value of the function at -1 is -3. And this is a nice slick trick to use, especially if the value may be kind of hard to plug in and find, and you do not have a calculator. So that's the remainder theorem. And again, you're using synthetic division. You're looking for it at an x value of 1. So you could also write this as p of -1. So if you see that, that is the number you put out here. You put these coefficients here, and you do synthetic division, and your remainder is what the value of the function is. Now, if the remainder was 0, what that means is that this thing right here, which would be 4x plus 8, would be a 0, and that means that this, so if your value of your function is 0, that means that this is going to be a factor. And that ultimately leads to what I want to talk about next, which is the factor theorem. So factor theorem, if I've got a polynomial and divided by that, if the remainder equals 0, then x minus c is a factor. And this is going to be really important when we start to factoring out some higher order polynomials. Okay, fourth, fifth, sixth order polynomials that you can't do the nice way we've been dealing with quadratics. What you do is we'll tell you how to guess what these c values are, and then you find the ones which have a remainder of 0. That means these are there. And then you have a remainder on top, or a quotient on top, and you just continue to factor down. Okay? And let's do a quick example of this, and let's start out with a problem we really know. So let's say I want to have a polynomial which is x minus 3, x plus 2, this should look familiar. That's x squared minus x minus Okay? Now, let's say this is all you have. But what I want to do is find out if x plus 2 is a factor. Now, I know you can factor this, but imagine if this was a higher order one with the cube, okay? So what you do then is we're going to use synthetic on this. So I'm going to take this number right here, change the sign, because that's a 0. And I'm going to put my coefficients of this up here, which is 1, -1, -6. Bring the 1 down. 2 times a -1 is a -2. Add it is a -3. 2 times a -3 is a 6. Add them. You got a 0. Bingo. Okay? That tells you that x plus 2 is a factor. The other thing it tells you is that x minus 3, which is what you get below here, is also a factor. So synthetic allows you to factor these things out. All right. The other skill you're going to need is finding polynomial or possible polynomials given some zeros. Okay, so let's say we want to find a polynomial with a degree of 4. That means you're looking for an x to the 4th term. And it has zeros of -1, 1, 3, and 5. Now you notice we have degree 4 and I have 4 zeros. So what that means is that none of these have to repeat. So now this becomes relatively easy. My polynomial will just equal 2. And this is my 0. So it becomes x plus 1, because if you plug a -1, it makes that 0. That's for the 0 equals -1. If you plug a -1 in, you get a 0, what we're looking for. And then we'll have an x minus 1, which is the 0 equals 1. Then we'll have an x minus 3, which is obviously from the 0 equals 3. And I'll have an x minus 5 from the 0 equals 5. Okay? So this is if they actually give you the 0. Now, they might actually come in and give you a graph of this thing. So how are you going to do this? We want to find a polynomial on this. And they're going to tell you you want here a degree equals 4. Well, the first thing you want to do is go in and find your zeros. They're here, 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 and here. You read these x values, and then you do the exact same thing that we did above. These will be your zeros, and then you plug them in just like my previous problem. So let's say we get a really bizarre looking guy. He looks like this. All right, and I want a degree equals 4. Now we know we're going to have an even one anyway, because my end behavior would go up in both the positive and the negative sides of this. So the first thing we do then is we come in and look for our zeros. And our zeros are at x equals -2 and x equals 3. Notice we have a degree of 4, but I only have 2 zeros. But if you remember before, when you take a look at this, what's happening with this thing is it's just coming down, and it touches here, and then it bounces back up. So what that tells me is this thing is repeated twice. So I'm going to get an x minus 2 here, and another x minus 2. And then the same thing. It comes down, it touches it, and then it bounces back up. This would give me, x plus 2, x minus 3, x minus 3. X plus 2 is x plus 2 squared times x minus 3 squared. So what this tells me, and this tells me, is that these 2 zeros are repeated twice. And remember, you have to change the signs for your zeros so that when you plug this number in, it makes that term 0.